So if we are told that x is anywhere between negative infinity and infinity, then the square root of x to the sixth, because it's x to the third and power 3 can be negative, I have to put the absolute value on it. Now, if I am asked to find the square root of x to the eighth, no matter what, x to the fourth is always positive, because we know that anything we raise to an even power will always be positive. There is no need to write the absolute value. So we use the absolute value only when it's needed. Also, if I have the cube root, let's say, of x to the ninth, I will never think of the absolute value because the index is odd. We never use the absolute value on an odd index. So 6 divided by 2 is 3, 8 divided by 2 is 4, 9 divided by 3 is 3. There is never a need of the absolute value on an odd index.
Awesome. Thank you so much.
Thank you. Now, for example, if I have, let's say, the square root of x plus 4, everything squared, I have to use the absolute value of x plus 4. I copy the base, and 2 over 2 is 1. If I'm told that x is any real number, what if it's negative 10? Negative 10 plus 6 will be negative 6. And the square root can never equal a negative number. But if I have the square root of x plus 4, let's say, to the fourth power, there is no ever a need of the absolute value on x plus 4 squared, because that is always, always positive, because it's squared. Any questions other than these? Or maybe you have questions on what I just said.
I was actually bad and didn't have time to work on it yesterday, so I'll have to do it this weekend.
Okay? But if there is anything that you would like to go back to, anything. Maybe we need clarification on anything else. Anything else? If not, we'll move on. Okay, so let's continue then with 8.2. We're trying to finish Module 8, and that is the end of the course. So we have time to review for Test 4. If you haven't registered, please do it immediately, and review for the final exam. So in 8.2 is really nothing major that we need to discuss, just to practice. And let me refresh your memory again. The nth root of x to the mth power is x raised to a fractional exponent. The power is always the numerator. The index is always the denominator. So please remember this. And again, I know I sound like a broken record. I always do. A radical can be changed into an exponential notation as long as the power is a fraction, and vice versa. So let's talk a little bit about the cube root. The cube root of 8 is 2. Why? Because 2 raised to this power is 8. So the cube root of 8 is 2 because 2 to the third is 8. Let's say the fourth root of 16 is also 2. Why? Because 2 raised to the fourth power is 16. Now with the graphing calculator, I want to show you a few things. And here it is. What I prefer, but that's me, I know that the fourth root, let's discuss this for a moment. What power is the fourth root? The fourth root. What power is the fourth root? If this is 1. What power?
1/4?
1/4, indeed. What power is the cube root if this is 1?
1/3?
Exactly. So this is my preference. I'll show you other options. My preference is to write 16, power symbol, which is a caret, and in parentheses 1/4. This is my preference. I think that this is shorter. I don't have to click, 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 click. And of course, when I click enter, I get 2. But there are other options. In math, you see you have to scroll down. This is the cube root, and this is any index. But you have to remember to put the index first, and then go to math, and then select 5, and then put in the number. Maybe it's the same amount of time. I don't know. It's up to you. So the same thing then, we will do this. I will put the index first. I will go to math. I will select 5. I will put 16. And then when I click enter, it gives me 2. For me, it's easier to just say, I know the fourth root is power 1/4. Why not do this? For some of you, the other route will be easier. It's up to you. You get to the same answer no matter what. So you decide. Good. Any questions, please? If you need me to show again or whatever you need, please stop me. Okay. Let's continue with other types of problems. For example, if I have negative the fourth root of 81, by the order of operations, I have to perform the power first. And you can say, what power? This. We established that this is a power. What power? 1/4. And then multiply by -1. Yes, you can use the calculator, that's fine. But that is 3 because it's 9 times 9, right? So if you use my method, or you can do this, you can copy because I already have a fourth root here. Second and entry. But be careful and just overwrite 16 by 81. And that's it. And when I click enter, I will get 3. And then that 3, of course, has to be multiplied by -1 in front. Therefore, I get -3. But careful, I'm not saying that -3 to the fourth power is 81, although it's true. No, 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 no. I'm saying 3 to the fourth power is this, and with minus in front. Let's say they're asking us to change 9, the square root of 9 to the third, into a power. How would you change this into a power? Copy the base, and then the exponent is what is the exponent? It has to be a fraction because I started with a radical. We just refreshed our memory on the rule.
1/3.
It's 3 divided by 2. The index is always the denominator. The power is always the numerator. So 3 over 2. 3 over 2. The index, it's confusing because we don't write it, but this is the only one we don't write. So 3 divided by 2. Now, I want to draw your attention to something here. We talked about this a long time ago. 3 divided by 2 is the same with 3 times 1/2, and it's the same thing with 1/2 times 3. We discussed this a long time ago. If you don't remember, I'll refresh your memory. We discussed something like this, actually. And I said when you see x over 2, please understand that this is 1/2 times x. Yes, it's also x times 1/2. But that's all I needed at that time. And we don't really write 1/2 x times 1/2. We write 1/2 times x. So x divided by 2, when I look at this, I also see this. The same thing here. 3 divided by 2 is the same with 3 times 1/2, and it's also the same with 1/2 times 3. Why am I bringing this to the floor, if you want? Because of 3/2, the power. What I'm saying here is that 9 to 3/2 can be written as 9 to the third, everything to 1/2, or it can be 9 to 1/2, everything to the third. This discussion is extremely valuable. You can say, I'm not going to do this because I'll use the calculator. Fine. But at some point in time, this needs to be understood. So, 3 over 2 is the same with 3 times 1/2, or 1/2 times 3. Why is this important? It's because I don't want to raise 9 to the third power, which is huge, and then take the square root. I'd rather take the square root of 9, which is 3, cube 3, and get 27. This is hard. This is hard. This is very easy. But I need to understand that 3 over 2 is the same with 3 times 1/2, or 1/2 times 3. I apply the square root first because it's easy, the square root of 9, because I know power 1/2 is the square root. The square root of 9 is 3. 3 to the third is 27. This is hard. I have to put in the calculator. This is hard because I have to raise 9 to the third power and then apply the square root. No. But if I understand, this is very minute detail that is extremely important. Very few students make use of this. Maybe they understand it, but they don't make use of it. So that I have to use the calculator on. This is huge because I have to cube 9 and then take the square root. But this is extremely easy, and this is in a blink. Square root of 9 is 3. 3 to the third is 27. So the answer over there is 27. Yes, you can say, I don't need this, which would be wrong, because this is really deep understanding of the roots. And you can just say 9 power 3 over 2, and I'm done. And I have to get 3, and that's it. I'm sorry, 27. 3 to the third, 27. And you're done. But if you want to understand what's happening next in math and have a good understanding and be able to progress faster, this is extremely valuable procedure. Okay, any questions on this? Again, this property is based on the commutative and associative laws of multiplication. 3 times 1/2 is 1/2 times 3. But if I apply it in this order, I get the answer in a blink. If I apply it in this way or in this way, it's way more difficult. Okay, here's another example. The 18th root of -6 to the 18th. Anyone has any idea how to get the answer here? You could say exactly how you did it before. Copy the base, and divide 18 by 18. Then you get 1. This will be wrong. Why? Why would this be wrong? Anybody remembers why? Because any even index is only applied to positive of 0. This is positive. Although it looks negative, but it's not. A negative number raised to an even power, this is a positive number. But also the answer has to be positive or 0. This is not acceptable. So the 18th root can never be negative unless there is a minus in front, but there isn't. An even root has to have an answer. So it has 2 major restrictions. One, underneath has to be positive, but this is. And the answer has to be also positive or 0. So then how do I address this to get the correct answer? Here's what I have to do. First of all, I'll say the following. I will simplify inside. Very easy to simplify inside because when I raise a negative number to an even number, negative number to an even number, I get a positive. And now I can copy 6. 18 over 18 is 1, and this is good. It's an 18th root. This must be positive. 6 is indeed positive, and this is correct. So the key is to simplify inside. You can also put the absolute value of negative 6. I prefer this route. Simplify inside, change that into a positive because it is. Negative 1 to the 18th power is positive. Positive 1. 6 to the 18th is 6 to the 18th. And now we copy the base and we divide the power by the index. Let's change negative 16 to 1/2 and see what this is. Anybody has any questions on this, please? Any questions?